Good morning, everyone. I will be talking about some of the ideas which we are having at NXP to add generic hardware accelerator support within the DPDK. The problem statement is very simple. SoCs have many different types of accelerator, and many of these accelerators are not common. Like if one vendor is supporting one accelerator in certain fashion, it's very difficult to find the other vendors doing in a similar fashion, or even they are supporting that kind of acceleration or not acceleration. There are few cases in DPDK we found commonality, just like event dev or traffic management, where we worked together with the community and we all together came out with the device flavors and added them into the DPDK. But there are still more accelerators which we want to add into DPDK. But the problem is how to expose them into DPDK. Should we go ahead and keep on adding new device flavors for each accelerator? Mind it, if some application is using this accelerator, they may not work on other architecture because in other architecture, these accelerators may not be available. And it's very difficult to find a generic way that all other architectures support the same set of APIs. Like one such example is one of the NXP use case. In NXP use case, we have a programmable engine called AIOP. So there are NICs which are directly getting connected from the bus to the DPDK. And then there is a AIOP, which is a programmable engine. That engine can expose optionally a NIC interface and a command control interface for the GPP side. All these interfaces are detected on a bus for the GPP. The application need to configure the accelerator using a set of API to use this accelerator. Right now, what NXP is doing, we are providing a set of library which is exposing a application level APIs to configure this engine using command messages. And some of the example applications are a complete OVS offload or a wireless offload to the accelerator. So one obvious question can come, why I want to do it in the DPDK? Why don't use a vendor-specific SDK API and use them? But that's not the feedback we are getting from the customer because they are telling us that we prefer a uniform device model, a uniform programming model. It's very easy for us to manage devices which are coming from a same framework rather than having two different completely orthogonal sets of APIs. And some of these accelerators may have to be integrated with the existing framework. One of the example is event dev. In the event dev, we will be waiting for the event. So we want these accelerator events also to come through that event dev. So can we find a common ground for such accelerators? We know that the management plane of these accelerators may not be common. And each vendor will have a different, but there can be something with respect to input-output which can be abstracted out. So if we see on a high-level point of view, what a typical accelerators will be looking for. They will be looking for a command control kind of APIs, a data IO API if they are supporting any data IO to GPP, a query API for statistics as well as status. Many of these accelerators work on the notification. They want to notify about a logs, event or exception packet, or even maybe real data may come as a notification messages. And then a firmware management, because some of these programmable devices depend upon the application uses. They may want to load one firmware or other firmware. They may not fit everything into one firmware. So based on the application usage, you want to use different kind of firmware. So one such thing, I came up with the idea that let's have a device called as raw device, which is a generic device, which will not have any standard configuration or input-output method assumption. It's a plain raw, as the name specifies, just a raw device. It can be a virtual device, which can be created on demand. The configuration, info, all the major structure may be opaque. Yeah, you're not specifying a particular structure where everybody has to follow. The queue and ring operation, again, may not assume any data format. The data, like right now, the operations, we are assuming that it will be mbuff or in crypto, they have a different format. But when we are talking with these accelerators, like let's have a void star. They may be supporting MBUF, they may not be supporting MBUF. And when we talk about the specific configuration API, we can very well have them, the specific PMDs, exposing them as a specific configuration API, because we know for sure that most likely they will not be portable across architecture. And if we find a region that multiple vendors are supporting, we can very well move this device from a raw to a specific device. The decision can be taken anytime, like when we find that more than one people are interested on a similar kind of accelerator. So just like there is a RTE device where right now we are supporting Ethernet DAB, Crypto DAB, Event DAB, we can support our raw device as well. And typical properties can be a typical common data which we generally know, device ID, queues, the private and infrastructures, the driver, the name, or we can have two kinds of operation. One from the firmware operation, which is again optional if you are loading, unloading, status, clock sync, or any kind of stats. And similarly, the raw device operations like which we generally have in other devices, but we can keep it limited, just like info-get, configure, start, stop. And if we are dealing with queues, if we are dealing with the statistics, we can use the extended stats, because we don't know what kind of statistics each accelerator is proposing. So another question can come. There was a model earlier proposed in the DPDK mailing list, programmable devices. So what we are doing different? What's the different we are trying to make here? So the last proposal for the PRG DAB was largely focused on the firmware image management. And in the raw device, we are just trying to provide a uniform device view and accelerator access to the applications. The raw device is not discounting firmware management, but makes it optional component. Not all accelerator need a firmware management. The raw device can serve as a staging device for any uncommon newly added devices. Like if you want to add any particular accelerator support into DPDK, you can initially put that as a raw device, and if you find more than one vendor or more than one party is interested in these kind of, we can try to make it common and move them into as a new device flavor. So that's my last slide. Any questions or comments?
Hi, I actually doing similar work right now, so I have a very interesting question for this, because currently like crypto dev QAT, right? Basically the device is exposed to the DPDK as virtual function, not really physical function. We basically leave all the former load, former management work to the PF driver, right? But according to your slides, it looks like you totally change that. You try to use DPDK PMD to drive the physical function of the device, not really use any virtual function, or I'm understanding wrong way?
So it depends actually. I'm trying to do both, if I say. Well, right now my initial use case is the physical function only.
Yeah, but by virtual function, how can you load or unload the firmwares?
So firmware is optional. This will not be available for the virtual function. That ops will not be available.
Okay. So basically, for your next level, you eventually will dealing with physical function, right?
Right.
Okay. Okay. Thank you.
So we're also doing a proof of concept on something similar, but it's slightly different in that, if I understand yours, you don't actually define any of the data structures. So they wouldn't be on the API at all, is that correct? They would only be known to the application and then to the underlying PMD, but not to the API.
What I'm suggesting, high-level API like start, stop, and that kind of API, but when we talk about the configuration or individual configuration component, I will let them directly the PMD specific API rather than a common API.
So do you see any difficulty with that, where an application that is coding against those data structures, but they're not part of the API? Because then you're taking them out of the API, not managing them.
Right.
Yeah, because I guess we're looking at an alternative at the moment, which is, it's not on the Ethernet side, it's on, or actually I suppose yours could be both, but it's under the CryptoDev, well, look-aside devices. but where we wanted a generic acceleration device as well. But in that, we're thinking a similar idea. The difference is that we want, say we were to use it for symmetric crypto. I know we've got crypto dev already, but for symmetric or asymmetric or other services, that we would define those as services, but they would have their own API and they would use an underlying accelerator device, which would do a lot of what you're talking about, config, but it would also include the data structures in the specific APIs. It's hard to explain right here without some slides, but we should talk about it offline maybe.
Just a very quick question. Why are you suggesting that this would be a VDEV? Why is it anticipated that these would not be discoverable on the buses? Because this is presumably backed by an actual hardware device, right? And the VDEVs more or less are all virtual devices or software devices. So is there a particular reason why you said this should only be created as a VDEV rather than an actual hardware device on a real bus?
So my reason for suggesting it was twofold. Like as my presentation says, just ideas. So my idea was like for each physical function, like even for a physical device, right now the way we are seeing, we are getting multiple devices to get one, to control one entity. So we've thought it's better to, rather than having a different physical devices and clubbing them somehow together, let's have a VDEV which will have the multiple physical devices underneath and multiple physical objects underneath, not necessarily DPDK devices, and control them. So my prototype right now, or the prototyping which I did, I prefer to use VDEV, but it's nothing specific out it. We can work out a physical dev.
So, Hyman, just with the approach that we've taken in RT security, instead of having a generic device type, the control APIs or the APIs are based on an instance base, so you have a single device that can have multiple personalities. So it doesn't require that you have a generic device type necessarily underneath, although I think maybe that would be a good idea. I think there's two device types really that exist. There's I/O devices and leukocyte type accelerator devices, and then you have control plane APIs that may be separate. I think for an approach, instead of having to create a new device, raw device type, if you have APIs, libraries that manage your control plane or your specialized function, depending on what it is, that if you can do a simple, take one single device ID and then use that across multiple different APIs, components, so you can discover if your I/O device supports switching. You can discover that, and you could have a switch API specific, but you're using still, maybe you have, like we've done in the security APIs, where we have helpers functions to convert your port ID to the security instance ID. That gives a much kind of more flexible approach, instead of having to have a very generic device model underneath.
So actually the problem which I found with that, what if my device is not matching to any of the existing device? Like for example, my command interface, it's not matching to any, it's not an Ethernet device, it's not a crypto device. So like what should I base it on?
Sure, so I guess in the possibility of the RT security, because it has an instance ID that's allocated from the security API, you could have a standalone security device which just is a control plane, because we're doing a conversion anyway from the port ID to a security instance ID, or we're doing it from a crypto device ID to a security instance ID. So you could just have a device that only instantiates a security ID, security instance. So I think that could be done. That sort of model would also work so it would still require then that you have a library that defines your new API for your control plane, specific control plane. But if you can discover that API, you could discover the instance, then you can use it directly. It's just another possible approach.
Okay, so
With these raw devices, you said that individual accelerators are still not compatible with each other, right? So the API is actually, when the application is written, it has to be written against a specific accelerator.
Yeah.
Okay, so what actually is the benefit of using this approach instead of using DPDK just for the common operations and having the config operations completely outside DPDK in their own vendor-specific API?
So this is a slide which actually I try to talk about this concept. Like many times what we are finding as a feedback from the customer that they want to look as a single place for device management. They don't want to use different kind of API, at least with respect to the device available. And they want a similar kind of programming model available.
Okay, but it's still different for different accelerators. Or
Yeah.
you mean, for example, what the customer wants is a single open function for both data and configuration? That's the kind of...
And the configuration does not mean necessarily a small amount of traffic. Like in some cases, it's not just the API which we are passing. In many cases, it's such a decent amount of traffic.
Okay, so there is a desire to move it all to DPDK, and that's
And the reason which I was proposing it, like what I feel, many of these cases may not be beneficial, like we just make it a generic API, because you may not find commonality between different vendors using a similar kind of API. So in some cases, we are already exposing some of the PMD level API, like just like a loopback in the Ethernet, some of the devices, there is a PMD loopback API, which is exposed from the PMDs now, not as a generic API.
Okay, thanks.
And also, I think I was looking at it from a slightly different perspective. It's more or less, you need to query this device, and the RT raw device is fine, I think, whatever, right? But there might be other devices as well. You query it, you find out what its functionality is, then you can actually then request a set of function pointers from a structure that says this is what it is. It may be unique to you, but at least you have a header file that tells you what those function pointers are and what the prototypes are. And I think that's what me and Bruce were discussing yesterday, and it's similar. We didn't talk about it in a device format, but we did talk about it as an API to query a device to ask for those list of function pointers. And I think that's what you're getting to is a generic way to get through DPDK, to get to any device, to find out what its capabilities are, and then what are the APIs you need to call to do whatever it's supposed to do. Sorry.
Rightly put. Thanks.
I don't know about the device layer part, but it sounds okay to me. I think just having a generic API in DPDK that says, get me this feature from this device. If it doesn't have it, it doesn't give you anything back, or gives you a no-op. Or if it does give you back a structure of function pointers, it gives you back maybe only 3 of them are filled in with a function pointer and the rest are null or something like that. We can have wrappers around it to make it easier to use. I think all those can work. We just probably have to put them all together and make them work correctly.
Okay, I think we'll wrap it there. We're going to have the questions after. So thank you very much, Hemant, for that presentation.